All right, so the last part of this section is to take a look at a general strategy and sort of discuss what might be a set of good choices. So for a general strategy, as I talked about in the end of the previous video, example 4, oftentimes we'll forget about this divergence test because it doesn't show convergence. It just is one way of showing that a series diverges. Now, this is not a guarantee. For instance, the harmonic series 1 over n from n equals 1 to infinity. If we apply the divergence test to this 1 over n term for the harmonic, the limit as n goes to infinity of 1 over n is 0. So the divergence test is inconclusive. So this isn't this isn't going to fix everything. But it is a very nice test because oftentimes I've encountered students spinning their wheels in the mud, so to speak, looking at a series and not knowing what to do. Like, I've tried geometric, I've tried comparison, I've tried limit comparison, ratio test doesn't seem to be working, or I don't know how to do the ratio test in this case. I can't figure out this limit. More often than not, it's because the one thing that this series needs to figure out is the divergence test. Sometimes that is just the ticket. Look at the sequence that gives the terms of the series. Are those terms getting larger, or are they approaching some number other than 0? If they are, diverges. Usually this is extremely quick. So I'm not saying that you should always do the divergence test first, because if I am presented with this series, I immediately recognize this as a geometric series. I'm not going to use the divergence test. But if I'm presented with something that's maybe a little bit complicated looking, I might use the divergence test here. Yep. As this expression here, as n gets larger, this becomes approximately equal to e to the n over 2 to the n, which is e over 2 to the n, which is, as n goes to infinity, this goes to infinity because e over 2 is greater than 1. So diverges. So don't forget about it is really the point here. After that, this is a list of all the tests we've talked about for positive series. So direct comparison test, limit comparison test, ratio, root, integral test. Ratio test is especially good if you have factorials present in your series term. So I'll just say good for handling factorials. Root test is good for things that are raised to the nth power, or things that can be expressed as something raised to the nth power, or maybe the 2n power, or something like that. The integral test is good. It's good if no other tests seem to work, or seem to easily, let's say, apply. And this is the kicker, it's really important, and you can integrate it. You can integrate the continuous analog. So what I mean here is if I have the series n e to the negative n squared, then I can take this expression and I can think of it as x e to the negative x squared. And if I'm going from n equals 0 to infinity, can I integrate this? So yes, this is this is a u sub, fairly straightforward integral. And of course, looking at this expression, it's not a p-series, it's not telescoping, it's not geometric. I don't know if ratio or root test would really work that well. Root test certainly wouldn't work that well. Ratio test might kind of be a little, maybe we could make some headway there. And limit, direct comparison, maybe we could play with algebra for 20 minutes and figure it out. But definitely, I think based on what we know about this series, since we know we could easily integrate this expression, might as well just use the ratio test, or excuse me, use the integral test, because no other strategies seem to be standing out. So integral test, I will say, between the integral test and the root test, these tests here are definitely, I'll say, very specific use cases. They're great when they work, but they don't work for a wide variety of problems, where these three, direct, limit, comparison tests, ratio test, I'll say a wide applicability. You'll be able to use these a lot. For non-positive series, the alternating series test, absolute convergence, this isn't a test, so I don't know why years ago I wrote that in my notes. But yeah, I would just think of the alternating series tests. That's really it. But keep in mind that the ratio and the root tests, they have absolute value built into them. So you can also use the root and ratio tests. Here as well, and they would work out nicely. All right, that should be a strategies.